Hello everyone. In this video, we shall see what is an array, how to declare an array, what are the advantages and disadvantages of it, and how to use it in a program. So basically, if we have written programs wherein we have calculated average marks of a certain set of students. Now, if you have many values, then you will have to give so many variables. Say for example, I have 5 subjects marks to be stored. Now to store this 5 subject marks, I have to declare 5 different variables. Say I have to give int, I need to give physics, chemistry, maths, then say social science and something else, computers, something like this. Okay, so I need to give 5 different variables, and I will have to give a variable for finding all this sum, and then I will have a float variable to find out the average, right? So I can give variables like this, or I can also give like this with same name like m1, m2, m3. So this way I can have 5 different variables to store marks of 5 subjects, right? These 5 variables are used to store marks of 5 subjects. This variable is used to store all these values, and this is a variable I am using to store the average marks. Now, if I have such 5 values, then wherever I am printing the values, or if I am reading the values from the input in both scanf and printf statement, I need to give these 5 variables separately. Like suppose if I want to read values of all these marks, okay, I have to give %d 5 times. So like this, I have to give %d 5 times, and all these variables list I have to mention with ampersand symbol, ampersand m1, ampersand m2. So like this it needs to be mentioned, which looks clumsy, and it is still manageable for 5 variables. What if I have 10 or 15 variables? Then it becomes extremely difficult to write it this way. So using scanf statement, or even while printing, suppose I want to find sum of this. In all calculations, I will have to write all these variables. I should write m1 plus m2 plus m3 plus m4 plus m5. Okay, so all these have to be written, which makes the instructions look very lengthy, right? It doesn't look good, and as I told you, it won't be feasible for you to write 15-20 variables. If you have multiple variables, it won't be feasible for you to write it this way. So to avoid this, we can declare arrays. So what is an array? An array is a collection of elements or collection of data items of the same type, of the same data type. Okay, now see, we have sum also. Sum is also an int variable that we are not going to combine here. All marks are of same type, right? Everything represents one particular value only. So like that, wherever you have all marks, say for example related values, such cases we can make use of arrays. So how to declare an array is, I'll give you the syntax for declaring an array. To declare an array, I need to mention the data type, and then array name, same as the variable name. Rules for array name is same as variable names. Whatever rules are applicable for naming variables and constants, same rules are applicable here. Here I need to mention the size or number of elements I need to mention here. So this is the syntax for declaring an array. Example, for the example that I just gave, wherein I need to store marks of 5 different subjects, and all are int values. So data type I will give int. Name of the array I will take it as marks, and how many values do I have to store here? 5 values. Int marks 5. Now I am going to store 5 integer values under a common name marks instead of having m1, m2. So for 5 values, instead of having 5 different names, I have a common name. Then how do I differentiate each of these 5 values? Using this index variable. So this is the common variable name for all these 5 values. Okay, and common variable name. And how do I access individual value? Using this index. It is called index or subscript. So we can call it as array index or array subscript. Now, how is the memory allotted for this? We have assumed 32-bit compiler, and in 32-bit compiler, memory required for an int variable is 2 bytes, right? Here I have 5 different values. So memory is allotted continuously. Continuous memory allocation is done for all these 5 values. 1, 2, 3, 4 and 5. So for all these 5 values, common name is marks, and to access each of these individual value, I need to use the index. Always the index numbering for an array starts from 0. So the last value is going to be whatever size I have given here, -1. So marks 0 refers to the first value. Marks 1 is our second value. Okay. So this is the first value in this array. This is the second value. And the last one is the fifth value. Now, how many bytes are allotted? As you know, every int value requires 2 bytes. So 2 bytes are required for this, 2 bytes are required for next value. So for all 5 values, we need 2 bytes. So 5 values into 2 bytes. 10 bytes of memory is allotted for an array, int array with 5 elements. Now suppose the memory address, every variable has a memory location. Suppose the memory address for this is 200. Suppose it is declared at 200, then the next value is after 2 bytes, which is at 202. Every byte has one memory location as a memory reference. So 2 bytes, 200 and 201 is occupied for the first value. 202 and 203 is occupied for the second value. So next value is at 204, next is at 205, next is at 208. So 2 bytes are allotted for each and every value, and that makes it 10 bytes in this case. Now how do we access this? As you know, it always starts from 0 and it is less than this number. We will be using a for loop to access all these individual elements. So we will write a loop, for loop. Will start the value from 0. You cannot take it from 1 to 5. It is always to be from 0 to 4. So 0 and I is less than 5. Or you can give I less than equal to 4, but we usually give I less than the size number, and we are going to increment it 1 by 1. And for every value, we are going to write a scanf statement where I am going to read one value, store it in the address of marks represented by I. Index number is I. When I is 0, is I less than 5? Yes, true. We entered the loop. Here, value is read from the input device, which is our keyboard, and that is stored at marks I. I is 0, right? So whatever value I give you here is stored in marks 0. Next, I gets incremented. I becomes 1. The next value that is given as input is stored at marks 1, which is this place. So next it is stored at this place. The next value here, next value here. Then when I becomes equal to 5, 5 less than 5 is false, we come out of the loop. So here if you observe, I have used a scanf statement with only one %d and only one variable name here, and this loop is going to read that many number of values as many I have given here. Suppose now the code is simplified. Suppose I give 50 elements. Okay, even if the array size is 50, all I have to do is just change this to 50. So if the size is 50 here, here also I am going to make it 50. Now this is going to read 50 values. So in the previous example where I gave you variable names, declaring 50 variable names and reading all those variables and displaying all that will actually be very difficult. Instead, here what we are doing is, we are giving a size here, we are writing a loop which will execute this many number of times. Now suppose you are not sure how many values you are going to give, then give a sufficiently bigger size over here, ask the user to enter how many values he wants to give, store that in a variable n, that n you can use here. So I have declared an array with 20 elements. So the number of bytes allotted will be 40 bytes, 2 bytes into 20 elements, 40 bytes will be allotted. And I am not every time giving 20 values. I am going to give a value which is stored in n. Suppose I want to give 5 values, I will give input as 5, that is stored in n. Loop is executed 5 times. If I give n as 10, this loop is executed 10 times. So we have a collective variables and named under one single name, individually we can access them using index and subscript. Now regardless of the size, whether it is an array of 5 elements or 50 elements or 100 elements, all I have to write is this code, and here I need to mention the size. So there is no need of writing a big scanf statement or a printf statement. Same thing holds good for adding also. Suppose I want to add all these values and store in sum. So I will write sum is equal to sum plus, sum is going to be declared as 0 in the beginning, plus every element of marks will be added. So as soon as you write an array, you have to understand for reading values, for accessing the elements, or for printing values, for all these things you will need a for loop. Using this for loop, you will be accessing all the elements from the first one to the last element, and marks I is going to denote each and every individual element in an array. So what all things that you need to remember about an array is, first thing is continuous memory allocations. It is called as contiguous memory allocation. Okay, contiguous memory allocation means memory is allotted one next to other. So if I have declared an array marks with 5 elements, all the 5 values will be stored one after the other. And random access is possible using the index variable. So random access is done using index or subscript. So it means suppose I have to directly access third value, I can do it. I need not give loop every time. If I have to read all the values or access all the values or print all the values, then I am going to give for loop. But if I have to directly access a particular value, suppose I want third value, I can directly use A2. A2 is where I have my third value. A0 is first value, right? So A2 is going to be third value. Random access is done using index or subscript. So directly if a particular value, if I want, I can access it using this index variable or the subscript. Okay. And size allotted. Memory allotted is equal to size into, that is number of elements into data type size. Okay, so whatever is the size of data type into number of elements, it is number of elements. Number of elements into data type size is the overall size allotted for that array. Now here, what are the cons of this? So there are certain disadvantages, or there are certain points that you need to remember. So in array declaration, so when we are declaring an array, we can't give a variable size. It must be a constant. In array declaration, size must be constant because we need to allot memory, right? So since we need to allot memory, we need to know how many values you're going to store there, because every value, suppose it is an int array, it will require 2 bytes for every value. If you want to allot 10 values, if you want to store 10 values, it will allot 20 bytes. If you want to store 5 values, it will allot 10 bytes. So size is must. It must be a constant. Based on that, memory is allotted. Example is, you must give int marks 5. Okay, or you can give float cost 10, something like this. Okay, this is accepted. You cannot write int marks n. This way you can't declare. This is not allowed because n is a variable. You cannot give like this, and you can't give blank as well. You must specify the size. So like this, without anything also you can't give. You must specify the size of an array, and that must be a constant. We can use macros also here. Say for example, we can have defining macros. I have already told you, hash define size 5. You can give like this, and in the main function you can mention, you can declare an array using this constant int cost. Here you can give size, but the size is a constant, right, which is defined earlier. This way also you can use, but you cannot use a variable name here in array declaration. So since we can't use variable name, we have to give a constant. We need to decide how many items are required, how many elements are required while writing the program itself. Later we can't change. Later if we have to change, we have to change the program. But while execution, we cannot decide on that. Therefore, we need to know how many elements should be given in the before writing program itself, and that is actually a drawback. Suppose you declare 30 or 20 as the size and you give only 4 elements, then if you are declaring 20 as a size, then you will have an array of 20 elements whose index starts from 0 up to 19. So we have 20 elements here. So how much we have allotted? 20 into 2 bytes, 40 bytes of memory we have allotted. Suppose I give n as 4 and I read only 4 values, then this is allotted memory. And how much will be used in case I give only 4 values? How many bytes will be used? 4 into 2 bytes. So only 8 bytes are used and remaining 32 bytes are not used. They are simply allotted but they are not used, right? So this is a disadvantage. If you are using very less of the array declared, then you might unnecessarily allot too much of memory but not use it. This is one disadvantage. One more disadvantage is, suppose you want to store 25 values, then it won't be possible because maximum size is limited. Maximum size is 20 only. So if you give 25 values or more than 20 values, it cannot store it. So that is a disadvantage. Okay. So these are disadvantages in declaring an array or using an array in our program. Here we have seen how to declare an array. Next we'll see how to initialize an array. Initializing an array. We have two types of initializing. One is static initialization and the other one is dynamic initialization. Static initialization and dynamic initialization. So in static initialization, we will be giving values in the code itself. In dynamic initialization, we will give during runtime. In static initialization, we are going to initialize the values along with the declaration itself. Example, I will give int marks 5 and these values should be given within curly braces and separated by comma. So I will give 38, 39, 42, 48, 45. Okay, so I have given 5 values, end it with a semicolon. Now I have allotted an array of 5 elements. Name of that array is marks and these are the values to be stored. So this will be stored at index number 0, this is stored at 1. So this way all these 5 values are stored in this array. Now if I declare an array like this and assign values, if I give less values, then the remaining 2 values will not be initialized. Say for example, I can give int a5 and I give values only, I'll give only 3 values, 10, 20 and 30. So in this case, 10 is stored in index number 0, this is stored in index number 1 and this is stored in index number 2. Whereas 3 and 4, these two index numbers will have junk value. Depending on the compiler, it might have junk value or it might have a basic value like 0. In case of int, it might have 0. But this is not wrong. This is not wrong. I have allotted memory for 5 elements, but I have initialized only the first 3. Remaining 2 are not initialized. We can give values to it later. Using dynamic initialization, we can give values later. That is the next example. So one more example is, suppose I give like this, without size. I told you we cannot declare a variable without size, right? But if I declare static initialization of an array, I can do it without size. So this way, that is only declaration is not allowed. Only declaration without size is not allowed, but declaration with initialization if I do, then without size it will be allowed. Here compiler finds out how many values are there, how many bytes are required to store that, and accordingly it will store. Here how many values are there? We have 4 values, right? So compiler will allot memory only for that many values. So now size of this array is 4. You will have 0, 1, 2, 3. Name of this array is A, 10, 20, 30, 40. So here memory is not wasted, but you can't store any extra values in this because you have not manually written the size, but you have given an initial set of values. Compiler will see how many values are there. That becomes the size of the array. If you give size, but if you don't give that many values, then memory will be allotted for 5 elements, but values are stored only in the first 3. In the remaining 2 you will have junk values. So these are different ways of assigning value to an array. Suppose you give 5 here and you give extra value here. Suppose you give 50. In this case you will not get any error, but since I have allotted memory to store only 5 values, first 5 values will be stored, last value will be discarded, but it will not give you any error. So this is about static initialization of an array. So coming to dynamic initialization, we will do dynamic initialization using for loop and a scanf statement, just as I had shown in the example little earlier. We will write a loop. We will always write I equals to 0 for arrays, I less than 5 in case of 5 elements, and I plus plus. We write a scanf statement and we read values one by one, ampersand, name of the array, and here you have to give subscript. This will read 5 values one by one using for loop during runtime. So whatever values we give, that will be taken during runtime using dynamic initialization. So this is about static initialization and dynamic initialization. And for printing, so for scanf and also for printing displaying values, we can use for loop with printf statement. Now let us see a program on how to declare this and how to access elements of an array. So I have created one empty file named as array.c. So here I will demonstrate how to use an array. I have already uploaded a program in which I have written the code and I have given explanation about how to find maximum and minimum element in an array. So you can go through that. Link of that video I'll be mentioning in the description, and right now it will also be flashing in the top of the screen. So you can click on that and see how to find maximum and minimum element of an array. More array programs are there in that playlist, you can go through. Here I am just showing a simple program how to declare an array, how to assign values to it, and how to display. So I will include the header file, hash include stdio.h. I'll write the main function. In this I'll declare an array with 5 elements. I need a variable I in order to use it in a for loop. Okay, I will ask the user to enter 5 values. Enter 5 values. Now to read this 5 values, I need to write a for loop. I equals to 0, I less than 5, I plus plus, scanf %d ampersand a I. Now this will read 5 values. Now I am going to display all these values one after the other. Printf values entered are, I will write a for loop again. For I equals to 0, I less than 5, I plus plus. We print these values one below the other. I will just write value %d, or I'll just write %d/n, and I am going to display AI. Okay, I have declared an array and I have a subscript variable which goes from 0 to 5 for reading the values. Again for printing I am using the same subscript variable from 0 to 5, and it is going to print the values. So ampersand is required only in the scanf statement, which I have told multiple times. Okay, so we execute this, enter 5 values. I will enter 5 values 10, 20, 30, 40 and 50. Now values entered are 10, 20, 30, 40, 50. It is displayed in one below the other. So because I have given /n here, it comes in fresh line. Every value comes in a new line. So this is an array. wherein we have multiple values with a common name. Individual elements can be accessed using array subscript. Now I will ask the user which value he wants. Okay. Enter the number of the value required. Okay. So now whatever user enters, I am going to store it in n. Scanf %d %n means I want nth value. Okay. So I will give value number %d is %d. So value number n is a n plus 1. I'll tell you why n plus 1. See, if I want first value, you know that array subscript starts from 0. First value is at location number 0, right? So second value, value number 2 is at location number 1. So if I want fourth value, it is at location number 3. So I have to give n minus 1 here. Now it is asking to enter 5 values. I will give 10, 20, 30, 40 and 50. Values entered are these. Now enter the number of value required. I want the fourth value. So fourth value number 4 is 40. Okay, fourth value is 40. So why I gave n minus 1, hope you have understood. For first value, subscript is 0. For second value, subscript is 1. So if I want nth value, subscript will be 1 less because it is starting from 0. Okay. So nth value is at location number n minus 1. This is random access. So every time you don't have to use a loop, directly also you can access a particular value. If I want directly third value or fourth value, you can use that as an index and you can get the value at that particular position. So this is about arrays, how to declare array, how to initialize it static and dynamic ways, and how to write a program we have seen. And as I told you, many array programs I'll be uploading in the other playlist, Coding Simplified, in which you have example programs. Those example programs are actually taken from popular coding platforms like HackerRank and HackerEarth. So it will help you in understanding how the questions will be asked in coding platforms. We have a Telegram channel in which all these source codes and lot of programming related study materials will be uploaded regularly. So link to the channel is mentioned in the description. You can join the Telegram channel and all these source codes will be uploaded there, and all the leading coding platforms programs with solutions will also be uploaded in that channel. See you all in the next video. Bye bye.